Exponential function graphs. Okay, here's an exponential function. Why is this called an exponential function? Because x is in the exponent. If you have a function where x is in the exponent, that's called an exponential function. How do you draw a graph? Well, we've never drawn any exponential function graphs. So when you have never done it, the obvious place to start is to build a table of values and use that to plot the graph. Okay, so let's build a table of values, x and y, and I'll just do 5 values, -2, -1, 0, 1, and 2. And for these 5 values, I'll figure out the y value. Okay. So let's start with x being -2. In this case, 2 to the x means 2 to the -2, right? Okay, what do we do about this negative power? What do you do? Yeah, you send it to the basement, right? Okay. What is that? 1 over 4. That's 1 over 4, right? So now you have y value as 1/4. Let's do the same thing here. X equals to -1. That means 2 to the x will be 2 to the -1. That means 1 over 2 to the first power, which is 1/2. Okay, so we have 1/2 for this value. Okay, what about x equal to 0? That means you have 2 to the 0th power, right? Anything to the 0th power is 1. Yes. Yeah, anything to the 0th power is 1. Okay, yeah. All right, so this value is 1. And the other two, you can basically do mental math. If you plug in 1 here, what's 2 to the first power? 2, right? 2 to the first power is 2. And when x is 2, what's 2 squared? 4. Right? So now we have 5 points. You have -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4. We're going to plot that on the grid paper and figure out what the graph must look like. Okay, so let me draw the grid here. Okay, let's say this is 1, 2, 3, and then 4, and then let's say here's 1, and then 2, -1, -2. Okay. Let's start with -2, 1/4. Here's -2 on the x-axis, and then 1/4 would be, this will be half. Half of half will be 1/4, right? So I need to plot somewhere this 1/4 and -2 meet, so the point that the graph passes must be this point. Next point is -1, 1/2. Where is that at? Here's -1, here's 1/2. They meet right here. Agreed? Okay, next. Where's 0, 1? Right here. And then 1, 2. X coordinate 1, y coordinate 2. Look where they meet. They meet right here. Okay, and 2, 4. X coordinate 2, y coordinate 4. They meet up here. Now, if you have this much information now, it's not too hard to see that the graph would look like this. Right? So that's the graph of y equals to 2 to the x. What I'm not showing you is we could also have plugged in decimals in here as well. Like, what if I plugged in 0.5? 0.5 will be 2 to the half power. 2 to the half power is same as square root of 2. Square root of 2 is about 1.4. So at 0.5, you get 1.4. If you have 1.5, that will end up being 2 times square root of 2, which is like 2.8. So it'll be somewhere here. So I can even do decimals, and if you plot more points, you will see that all the points will be smoothly giving you this curve. Okay, so that's the graph of y equals 2 to the x. Now, there are two things that we learn from this. There are two things that we learn from, actually, I would say three things. There are three important things that you should know about this graph. The first thing is, as you go left, the graph gets closer and closer to what? 0, right? So if you draw this horizontal line on the x-axis, what's the equation of a horizontal line? No, y equals to some, x equals to a number gives you a vertical line, right? So if you have y equals to a number, that gives you a horizontal line, and this one specifically is y equals to 0. So y equal to 0 is what we call a horizontal asymptote. Yes, horizontal asymptote. It's a horizontal asymptote because if you were to draw this further, at some point, this curve will get so close to the dotted line that it will be indistinguishable. You'll only be able to distinguish the two when you zoom in. And if you zoom in, you'll see that they're different, but if you see it from the distance, they'll look exactly the same, okay? So the curve and the dotted lines are indistinguishable. That means the curve gets closer and closer to this horizontal line. Such a horizontal line is called a horizontal asymptote. Is that okay? The line where the graph gets closer and closer to, which becomes indistinguishable, that's called a horizontal asymptote. Now, secondly, there's just one intercept, and that happens to be a very important number for you to know. So this graph will have 0, 1 as its y-intercept. Okay, when drawing the graph of an exponential function, because it doesn't pass through the origin, 0, 1 will be a reference point that you should always be aware of. Okay, and then thirdly, on the left side it goes close to 0, but what happens if you go to the right? It goes up and up and up without bound, right? So that's called the end behavior, right? So we see that the end behavior on this side, on the right side, is like that. It goes up and up without bound. Okay. All right, so those are the three facts about the graph of an exponential function. Now I want to show you a second example. This time, let's try to draw the graph of y equals to 1/2 to the x power. And we're going to do the same thing. We're going to take x and y, and we're going to put -2, -1, 0, and 1, and 2. And over here, we'll try to fill this in. Now, notice that this one and this one, although they look different, they basically have the same property, which is you have a number and the x is in the exponent, right? You have a number and the x is in the exponent. So these two will share something very similar, okay? But they will also be different in some way, and that's what I want to observe, okay? All right, so let's do this for each value. First, what happens if you have -2? Okay, if you have negative power, what happens? You bring it down. Or another way to say it is, if it's a fraction, it simply does this, okay? See, one way to see it would be, if you have this, then this will be affecting both of the exponents. So you have 1 to the -2 power, 2 to the -2 power, just like that, right? And then this goes downstairs in the basement. This goes above ground. That's what you get, right? So that's going to be equals to, what's 2 squared? 1 squared is 1. So 4 divided by 1 is 4. So you get a 4. Okay. So that's one way to see it. Another way to calculate is simply say, well, negative power means you flip upside down. So it'll be 2 over 1. What's 2 over 1? 2 divided by 1 is 2. And then you have 2 squared. What's that? 4. Okay. So there are 2 different ways to get the same thing. Hopefully that convinces you that the value of y when x is negative 2 is 4. I kind of like this one better. This one looks more involved and confusing for me. So let's just stick to this way. Anytime you have a fraction with a minus, you flip upside down. Okay. So let's agree on that one. All right. So you have 1/2 to the negative 1 power. What do you do again? Flip upside down. So you have 2 over 1 to the positive first power. What's that? 2. Right? So that's 2. Is it okay? 2 divided by 1 is 2, and 2 to the first power is 2. All right. What's anything to the 0th power? 1. Okay. What's anything to the first power? It's itself, right? So 1/2 to the first power will be just itself. And then finally, when x is 2, 1/2 squared would mean that you have 1/2 times 1/2, because square means you multiply it to itself, right? And that's going to be 1 times 1 over 2 times 2, so it's going to be 1/4. It'll be 1/4. Okay, if you compare the values from the previous graph with this one, oh, there's some kind of nice symmetry going on here. Do you see it? Like here it's 1/4, 1/2, 1, 2, 4, and if you go backwards, it's 1/4, 1/2, 1, 2, and 4. Okay. Now, because they have some symmetry, instead of drawing a new graph for this, I'll try to draw it in the same picture. Okay, so let's try to draw the graph on the same picture. First, at negative 2, you're at what? 4. Negative 2, 4. You see that? Negative 2, you go all the way up to 4, so it's here. And then negative 1, you're at 2. Negative 1, you go up to 2. 0, you get to 1. 1, you get to 1/2. 2, you get to 1/4. Okay. And then you connect these, and you get this other graph. And you see some kind of symmetry. What kind of symmetry do the 2 graphs have? How do you get this second graph from the first one? By doing what? You flip over the y-axis, right? If you flip the first one by the y-axis, you get that. Okay. Now, that's kind of mysterious. Like, how would you know that if you have 1/2 to the x power, this is going to give you a graph that's going to be something that's flipped over the y-axis? Mystery, right? Do you see the mystery? Yeah, why?
It's kind of flipped because 2 over 1 is the opposite of 1.
Yeah, but how do you know exactly that it's the flip over the y-axis? I don't think that really explains. I mean, it's kind of, yeah. What's your take?
I was going to say, if you look at the y values of the reverse.
Okay. So that's like you can argue by just looking at the points there, like it's flipped this way. But I want a better explanation. So let's go back to think about how the procedure for figuring out reflections are done. So I explained that whenever you have to talk about reflections, you should draw this axis, label this as x and y, but then this part will be what? Negative x. This part should be negative y, right? And then say, well, if I want to flip over the y-axis, what should I do? What does this picture say? If I flip over, what should happen to x? It should become negative x. What should happen to y? It stays the same because if this y is up here, when you flip this way, it's still up here. It doesn't change, right? So y stays the same, and then x gets replaced by negative x. So to resolve this mystery, I'm just going to take this graph, y equals to 2 to the x, and I'm going to reflect this over the y-axis. I'm going to flip it over the y-axis. Okay. So what should I do with the y again? Replace y by itself. No, it doesn't change. If you do this, y stays the same, right? We just agreed on that, right? So y stays the same. Okay. What do you do with x? X becomes negative x if you flip, right? So we put negative x. Okay, so we have this. But wait, negative exponent, what does that mean? That means it's 1 over 2 to the x, right? And you can even rewrite 1 as 1 to the x over 2 to the x, because 1 to any power is 1. You know that, right? 1 to, what's 1 to the 100th power? 1. 1 to any power is 1, right? So you can rewrite 1 as 1 to the x and then say, oh, this is same as 1/2 to the x power. Ah, no wonder. So that's why, see, if you took this and simplified, this is same as just 1 over 2 to the x, which is same as 2 to the negative x. These are really the same thing. Okay? Except that if you see it this way, it's hard to tell that it's a reflection over y, whereas if you write it this way, it's obvious that it should be the reflection of over the y. Okay. All right. So hopefully this resolves the mystery, and you have two good examples of exponential function to work with. Because now, from this example, I'm just going to tell you what happens in general. So in general, let me just erase this one as well. Okay. So in general, if you have the graph of y equals to a to the x, there are two possibilities. If a is bigger than 1, then the graph is going to increase like that, just like this graph. When, say, 2 is bigger than 1, right? So it's going to increase like that. Okay. On the other hand, if a is less than 1, and by the way, we never consider negative to some powers, so we never do negative to the x. This causes a lot of trouble, especially when x is like 1/2, you end up with the square root of -2, which is not a real number. So we don't deal with that. We only deal with the case when a is bigger than 0. Okay? So for that case, the graph is like this other one. See, this is the case when a is 1/2. When it's 1/2, it falls down to 0. So the graph goes down like this. Okay. Now, I don't want to stop here, but have some more understanding of why, if a is greater than 1, it should be like that, and if a is less than 1, it should be like this. Okay. So think about what this is doing. You're multiplying by 2 every time x increases by 1, right? So when x is 1, you get 2. When x is 2, you double that, it's 4. When x is 3, you double that again, it's 8. You put 4, and then you double that yet again, it's 16. So every time you go to the right, what happens? The y value increases like crazy, right? The numbers go up very fast. That's why it's called an exponential. I mean, that's a property of the exponential function. Exponential function grows very rapidly, right? Yeah, so as an example, which would you rather have? Like get $100,000 as your daily salary for 1 year, okay? Or you start with $1, but every day your salary doubles. Every day the salary doubles. That's like incomparably much bigger than having $100,000 every day. Okay, so see, this exponential function, they increase like crazy, right? Now, on the other hand, if you have something like 1/2 to the x, that means every time x increases, you're getting half. Okay? So, I mean, let's assume that you've inherited like $100 million from your rich parents, but your rich parents were killed in the streets of New York City. Something like the superhero movie, right? Yeah. Okay. But yeah. All right. So. Imagine you're Batman. Yeah. Okay. Yeah. Basically. Yeah. Yeah. But then. You got so much money. All right. All right. Okay. Okay. Yeah. But then you really don't have financial intelligence, and you just spend like crazy. Every day your money goes by half, right? What happens? Pretty soon you'll be homeless, right? So that's what happens to this graph. Like every time you go, the value becomes half and half of half and half, so it becomes 0 pretty quickly. Okay, that's what this other graph is about. That's what this graph is. All right. Okay. Now let me throw just one more special case. What if a is exactly 1? What would it be the graph of 1 to the x power? It's a straight line because it's always 1, right? Yeah. If y is equal to 1 to the x power, then it's just always 1. So you have a horizontal straight line. Right? Okay. So that will be the graph. But a is equal to 1 rarely appears, so you don't have to remember this as a separate thing. You just have to remember these two shapes. So I'm going to do a few of these graphing problems today. And your goal is to graph it and also find any asymptotes or intercepts if there is any, right? And the aim is to try to draw the graph using your knowledge of transformation. So if x is replaced by x minus 2, what happens to the graph? It moves 2 to the right, right? What about this plus 3? What does that do? It moves 3 up, right? So what we're going to do is we're going to start from y equals to 2 to the x, which I know that this is the graph. And I asked you to remember 3 things, but really just 2 things are important. One is that this point right here is 0, 1, and y equal to 0 is the horizontal asymptote. This is a must. Just always pay attention to the 2 properties of y equals to 2 to the x, that 0, 1 is a point on the graph, and y equal to 0 is the horizontal asymptote, right? So we're going to focus on that one, and then say, well, we just said it moves 2 to the right and goes up by 3. So if it's 0, 1 and you move 2 steps to the right and you go up by 3, where are you at? Where's this new coordinate? So this point right will be 2, 4, right? So 2, 4 will be this new point that this graph is going to pass through. Does that make sense? Right? Because the previous graph passed through 0, 1, 0, 1, the new graph is going to pass through 2, 4. Yes?
Where do you get 2? Oh, wait, no.
Yeah, 0, 1, if you move 2 steps to the right. Okay, 0, 1, 2 steps to the right. Where are you at? 2, 1. Now, go 3 steps up. Where are you at? 2, 4. That's where we got the 2, 4, right? Okay. Now, what about this horizontal line, y equal to 0? If you take a horizontal line, moves 2 steps right, what happens to the graph? Stays the same. Horizontal lines, if you move left or right, they stay the same. They don't change, right? But then, what does this plus 3 do? Moves it up. So what's the new graph? New horizontal line. That's y equals to 3. So what you have here's 3, and you're going to put this as a new horizontal asymptote, and the graph passes through this point. The shape is still like that, so we're going to draw the graph as like this. Okay. So that's the graph of y equals to 2 to the x minus 2 plus 3. And along the way, we actually solved another question, which is that the asymptote is what? Yeah, asymptote is, well, there's a horizontal asymptote, which is y equals to 3. Okay, so that part we knew. Okay, looking at the graph, is there any x-intercept? Do you see any x-intercept? No, it doesn't cross the x-axis ever because we took the graph. This doesn't have any x-intercept. It doesn't cross the x-axis, and we moved it up. So again, it doesn't cross the x-axis, right? Okay, so now what we do is we're just going to look for the y-intercept. Okay, what is the y-intercept? How do you get the y-intercept? You set x equal to 0. That's how you get the y-intercept, right? So you have y equals to 2 to the 0 minus 2 plus 3, which is 2 to the negative 2 plus 3. What is this negative power? What does that do? 1 over 2 squared plus 3, which is 1/4 plus 3. Oh, I have to add a number to a fraction. What do? You first make the 3 as 3 over 1, multiply 4 top and bottom, so you have the same denominator. You need common denominator, so you have 1/4 plus 12 over 4, which gives you 13 over 4. Okay, so that's going to be your x-intercept. No, y-intercept, sorry. Y-intercept. Okay, so the answer to this question is you have this as the picture. Horizontal asymptote is y equals to 3. There are no, I should write here, no x-intercepts. And then we plug in 0 to get the y-intercept, which is 13 over 4. You get that? Is that good? All right. So let me put 2 more questions in the similar manner. See if you can draw these. So let's try this one. You have to start from y equals to 2 to the x. What are the 2 things that you have to remember about this graph? Y-intercept is 0, 1, right? And what's the horizontal asymptote? Y equal to 0 is the horizontal asymptote, right? It's like that. Okay, remember? Now, x now became x plus 1. What's happening to the graph? Moves left by 1, okay? And then minus 4, what does that do? Down 4. So this point, which is 0, 1, now move 1 left. Where's this point? What's this? What's the coordinate for this one? Negative 1, 1, right? Yeah, because you move 1 by left, okay? Now you go down 1, 2, 3, 4 steps down. What is this coordinate? Negative 1, comma, negative 3. Okay, so this point right here is negative 1, comma, negative 3. Okay. So the graph must pass through this point, go 1 step left and go down by 4. Okay, now let's see. What about the horizontal asymptote? What's happening? This thing at 0 is going down by 4, so this dotted line is going to go 1, 2, 3, 4 steps down, so you'll be right here, right? And this should be negative 4. Okay? So what's the equation of the horizontal asymptote? Y equals to negative 4. You get that? Okay. Now let's try to figure out the y-intercept. How do you get the y-intercept? Set x equals to 0, so you have y equals to 2 to the 0 plus 1 minus 4, which is 2 to the first power minus 4, which is 2 minus 4, which is negative 2. So the y-intercept is negative 2. In this graph, it's right here, negative 2. Okay? So we have this point, this point. Okay, what about the x-intercept? Well, x-intercept, we haven't done much about x-intercept. This is the first time we're doing x-intercept. We say y as 0, so 0 is equal to 2 to the x plus 1 minus 4. Let's move the 4 to this side, which is 4 equals to 2 to the x plus 1. And then you want to rewrite this 4 as 2 squared. You get that? You rewrite this 2 squared. And now compare the two sides. I see a 2 here, I see a 2 here. That's good, right? We're trying to set them equal to each other, so if I have a 2 here, I see a 2 there, that's good, okay? But then I see a 2 here, and I see an x plus 1 there. What does that mean? What's the upshot? For these two to be equal, I need it to be 2 equals to x plus 1, right? Now subtract 1 both sides. What do you get for x? X equals to 1. So I know that the graph must pass through 1. And see, now I have a graph that passes through these 3 points, and this is the horizontal asymptote going this way. So that's the graph. Okay, that's the answer. Let me do this one quickly. This one, if you just have y equals 2 to the negative x, what's this? You're taking this graph, but x and negative x are switched. What does that do to the graph? it flips over the y-axis, so the graph is going to go like that, right? Now what does this do? Brings it up by 4, so now you have horizontal asymptote at 4, and then it goes like that. Okay, what's this point? 0, 5, because it went, see, originally it was at 0, 1, but it goes up by 4 steps, now it's 0, 5. Does it have an x-intercept? No, no x-intercept, horizontal asymptote 4, 5 is the y-intercept, and that's it. That's all we need from here. That's all for today.